This is session 7, and I'm going to start working with the time value of money, the issue that we deal with in terms of bringing future values back to the present. For public projects, this is very, very important, and the process of calculating a present value is fraught with some issues. First of all, costs for projects are generally mostly up front. We call them lumpy. They tend to be, you tend to pay over the course of building a bridge or a building or a facility or a hospital or starting up a new program. Most of the costs tend to be up front, the big chunk of costs. So those are here and now and known. We know these values, and they're up front. But benefits tend to accumulate slowly over time. There's an increment to well-being that starts to show up, and it might start out kind of slow and grow over a period of time. So they trickle in. So costs are up front, and the benefits tend to be strung out. So how do you compare something when over a reasonable period of time we have the costs right here and the string of benefits way out here? We have to figure out a way to do that, and we do that using present value calculations. And we also have to think in terms of individuals and communities. We tend to value goods in the present instead of future goods. If I'm given a choice between, on a date like today that's going to be 95, drinking a cold Coca-Cola when I get done with this class versus drinking it tomorrow, I'm going to drink it today. I prefer satisfaction today. I'm not going to, on a 95-degree day, defer that refreshment for the future. So so how do we reconcile this preference for present consumption, which says, I'm not really interested in investing, I'm not really interested in spending on new bridges or roads, I want that money for myself right now, versus the need to create public works, public goods, and or programs that have a long lifespan and serve us for a long period of time. So how do we reconcile that? Well, we have to take into account time and our preferences into consideration. And we already know, we've talked about this, money over time is worth less due to inflation. We know that over time our relative purchasing power of the dollar goes down. It goes down at an overall relatively fixed rate inverse to the rate of inflation that there is. But we don't know how much it's going to decline. In the 80s, my purchasing power devalued rapidly. In the 1990s and into this decade, for a period of time, there was very low inflation. My purchasing power did not go down rapidly, just due to inflation. So it's variable, and it's variable. And I'll give you an example. Say exactly 1 year from today, in appreciation for superior performance, I will award you one of these 3 things. And you think about this. I will give you 4 ounces of gold. I think gold was trading today at $970 per ounce. But that's today. I'm talking about a year from now. I will give you 4 ounces of gold, 1,000 gallons of unleaded gasoline, or $4,000 cash. Which would you choose? Well, let's think about how we would value that. A year ago, the prospect of getting 1,000 gallons of gasoline being the equivalent of $4,000 in cash was not an unreasonable prospect. Gasoline, I paid $4.30 in 2008 Memorial Day driving to Cheyenne, Wyoming. And that was a lot of money for gasoline. It's the highest I'd ever paid at that time. So a year ago, you may have had a different attitude about gasoline than you do this year, when gasoline this morning, in the case of the middle of 2009, was selling for $2.45 at my local gas station. Gold has been as high. It was early this year. It was very high. And then it went down. We have all kinds of variability. And then $4,000 in cash. But $4,000 in cash a year from now is not going to be the same purchasing power as $4,000 in cash today because we have inflation. Well, do we have high inflation or do we have low inflation? What are your expectations? So each of you would value these three commodities differently with regard to where you are in the present, and what you think the future, and then what you think is going to be worth the most. Well, you don't know. You haven't a clue as to whether the gold, the gas, or the cash is going to be worth more a year from now. You might think you have a very good guess, but if you were a very smart person last year on June 10th, you would have guessed wrong, because by June 20th everything had changed or July 20th everything had changed in our economy. Instead of a period of very, very rapidly rising gasoline prices and food prices, by July 20th, we had a period of collapsing energy prices and collapsing food prices, and they continued to go down into the fall. Everything you would have guessed on June 20th would have not served you well in August. And so you don't know. We have uncertainty. And if you had to choose today, which would you choose? Well, you figure it out. If you want to know which one I'd choose, I always take the money. It all depends. Your current needs versus your sense of future needs. Tension between consumption and savings. Consumption and savings. Consumption and savings. Would I take the gold knowing that it's going to be worth a lot more in the future? Would I take possession of the gasoline knowing that it's going to be worth a lot more in the future? Or would I just take the money because I need stuff? Okay, your personal expectations of gain and loss. Then there's a bundle of intangibles, and it's just how you were raised or whether you come from a culture that prizes certain things over other things. What if I said I'd give you one of these items in 5 years instead of one? Which one do you think might be most valuable? My guess is the gasoline. So no matter what, we have to discount the future. But how much? And that's the problem. How much do we discount the future? What's going to be the nibbling away of my present value, of my commodities or my incomes? I gave you money and I gave you a commodity. The commodity, because of inflation, tends to go up in price. The purchasing power of the income, the money, tends to erode over time. Where is the balance between those two? So let's go through this exercise, and I don't know that it's going to work very well, but I love doing this exercise, and I don't care if it does or not. Imagine that you have, this is for all of my female members in specific, but that you have a rich and controlling Aunt Agnes, but she's died, bless her heart, and she's willed you a fixed annuity of $10,000 a year for the next 10 years. That sweet woman, controlling yet sweet woman, is giving you $10,000 a year, and you get to get your first check in a year. 1 year from now, you're going to get. So let's pretend that's a stream of benefits. It's obviously beneficial to you, isn't it? You get $10,000 a year for 10 years starting in a year. So you have a stream of benefits. So the nominal value in today's dollars is $100,000. But the real value to you in terms of, and when I'm using the word real value, is your purchasing power is going to depend on several things. And one is the rate of inflation and all other kinds of things might be affecting, including your personal preferences. The value of that money actually is influenced by what you want to do. And here's what's the deal. You're impatient. And Agnes knew this. Aunt Agnes knew about your impatience. And even from the grave, she's reaching up and she's trying to control you. But you are smart. You want to borrow against that annuity and sail the Caribbean this summer with your newfound friend or companion, Enrico. who's quite impressed with your recent good fortune, who just happens to know of a boat for lease from his cousin Eduardo. You're going to have a blast. And you got money. You got money. So, but how do you get it? You don't get that first check for $10,000 for a year. And Enrico, he seems impatient. And so how do you get enough money to sail the Caribbean and have the fun you always thought you deserved? You've got a stream of future income. It's guaranteed. It's in the will. The money's there. Not to worry. What do you do? So what you need is you need to cash it out. You basically need someone to buy that income stream benefit from you. But what would they be willing to offer for that annuity today? Well, we've got to figure out. We've got to calculate the present value of that annuity. And we're going to call it your benefit. Or it could be a cost, but in this case it's your benefit stream. And to discount the future values back to the present values, FV or future values, back to the present values, we have to use a little calculation. And knowing how to do this and why is one of the fundamental tenets of benefit cost analysis. Now, this is very easy. I think I may use the overhead as well. But we're going to look at if I can find my, whoops, go back. I have to find my, bifocals are awful, but I'm going to find my felt tip pen. Okay, so the present value of any future value is written like this. The present value of something is equal to some future value divided by 1 plus the discount rate to the n power. Okay, so now the discount rate, let's just call for the time being the discount rate the rate of inflation. Let's say it was 3%. So the present value of a future amount is going to be the future value divided by 1 plus the discount rate. 1 plus, let's say it was 3%, 1 plus 0.03 or 1.03 raised to the how many periods in the future you're talking about, you're trying to bring back to the present value. So we can add a stream of discounted future values to arrive at a present value of the future amounts. Let me go over to this thing real quick here. And is that up? Yeah. Let's dial in just a little bit. So I'm just going to write them. I'm not going to do the calculation. But we're going to have the present value of something. And let's say that it's $10,000. What's going to be the present value of a future value, which is going to be $10,000? And I know I'm going to get it next year. I need to discount it, though, to right now because Enrico's waiting. So it's going to be, and I said, let's just say it's the value of it in terms of controlling for inflation. It's going to be 1 plus the discount rate, or in this case I said it's the inflation rate, 0.03, and it's going to be just in year 1. And so you're going to be dividing $10,000 by 1.03. But in the second year, so that's present value, the present value at time 0. In the second year, the present value at 0 is going to be, it's going to still be that annuity divided by, now it's 1.03, but it's to the squared power. It's squared. And so if you're squaring 1.03, the denominator is getting larger, and the value then, the present value, is getting smaller. Well, that's the process of discounting. This is what we mean by discounting a stream of values over time 1 through time n. And this is fundamental to benefit cost analysis. You discount your benefits and you discount your costs. And all of you can do this. This is no big deal. So, but we have to decide on the appropriate discount rate. Now, how much should we discount the future values? How much should we discount these future values? Would we use the average rate of inflation over the past 10 years? Let's say it was 3%. Now, think about that. Would somebody say, oh, I'm more than willing to just break even on the deal relative to inflation and not considering my tax liabilities or anything else or my costs of thinking about this. I'm just gonna take care of you by offering you a 3% discount on that money, and I'll just write a check. Do you think so? Or would we use a more realistic number, because whoever's going to be offering you this money is going to want a little bit of a return on this money, and so it might be the average after-tax return on savings and investments, and let's pretend it was just 5%. 5%. Things haven't been all that great, but 5% after taxes at a 5% rate, that's okay. That's not bad. So maybe I do that. Or your own personal rate of consumption. Enrico's waiting, and you have a high need to sail the Caribbean. And if you have a high need to sail the Caribbean, then maybe your personal discount rate is extremely high as well. So pretend it's 7%. 7%. And the person who's looking at you can tell that you really prefer consuming in the present versus waiting for that money. And so that person says, well, I'm going to use a 7% discount rate. Well, what's going to be the differences in the values? Well, we can calculate that, and I think I'm going to just do it manually, and so I can give you an initial example of what that would look like. And let's go to Excel. Up here, written in really nice, great big letters for all of you folks who are sitting way back on your couch, is the benefit stream. Now, the nominal value of this benefit stream, it's 10 years worth of $10,000. And this is kind of like the lottery. Remember, you know how the lottery says you're going to win $1 million paid out over 25 years. Well, you're not going to win $1 million. Nominally you are, but in terms of purchasing power, no, you're not. And it's false, it's phony, it's deceptive advertising, and the states all ought to be put in jail for lying. But that's aside the point. So let me sum that up, and so I'm going to sum that. And so my nominal value of that is $100,000. And why can't I see that? It's because I've written that in white ink. Here we go. So it's $100,000. That's the nominal value. That's the amount that was in the will. That's the nominal contractual obligation between Dead Agnes and the will and you. So there it is. But you don't have that money. Matter of fact, you don't get the first dollar until year one. So what we have to do is we have to discount those future values. So what I'm going to do is I'm going to discount using the formula I just showed you. I'm going to do this. I'm going to say, I want to know what is this, the present, what I'm going to want to know is what's going to be the present value of $10,000 divided by 1. Now I've got 3 discount rates up across the top. I just talked about that with you. So it's going to be 1 plus my discount rate up above, and let's put a $sign in front of the 2 because I'm going to be copying this down. And then I want to take that to the nth power. What's my number of years or periods that I'm dealing with? Well, I've put those over here. Here's year 1. And so, and then as that goes down, that element gets bigger and bigger because I go to 2, 3, 4, 5, 6, 7, 8, 9, 10. So as I copy that down, it does that work for me. So look what happened. Just at 3%, the purchasing power has gone down in year 1. It has gone down in year 1. Now let's just copy it across first. Look what happens at a 5% discount rate. Whoops, I got to change that formula, I've got to put a dollar sign in front of the A. Do that, because I'm always reading from column A. Now I'll copy it across. Look what a 5% discount does, the present value of that, just next year's $10,000. At a 5% discount rate, the bid price on that is only going to be almost $92.50. And look what happens at a 7% discount rate. So you see it's $8,642. So you see the discount rate that you choose makes a big difference in the value of this money at the present. So here, let's do it this way. Let's pretend it's this way. Let's just pretend it was all inflation. If $10,000 a year from now, given a 3% inflation rate, will only buy $9,709 worth of goods that we could have bought in the present. To say it differently, what only cost us $907 today will cost us $10,000 a year from now. That's the easiest way to say that. And if it were a 5% inflation rate, what only cost us $92.46 today will cost us $10,000 in a year. And if it was a 7% inflation rate, what only cost us $8,642 will cost us $10,000 in a year from now. So you see what happens, the effects of inflation eating away at our purchasing power. Well, let me copy these all the way down to the end and look at how these values devalue given your assumptions about the inflation rates. At 3%, they don't look all that bad. They just don't look all that bad. And this is kind of the effect of what inflation does to us currently in the current period. At 5%, look at this. It's gotten down to less than half. Remember, we're calculating back to present value. That those future values, you're only going to be able to buy half as much as you could in the first year. You're just losing all kinds of purchasing power over time. And then look what happens way out here in the way out period at a 7% discount rate. At a 7% discount rate, the future value of that money is pretty darn low. Well, let's sum this all up. I'd already summed it, so let's copy it across. What I want to know is what's the present value of all of this? What's the present value of that stream given my discount rate? Well, if all I'm thinking about is inflation, it's $85,000. Somebody who was very generous would say, oh, I'm not going to worry about my costs. I'll give you $85,300. Have a great time. Wouldn't that be a good deal? Somebody who was thinking in terms of getting some sort of modest return on their effort might only offer you $66,650. They're going to look at you and say, look, I'm a business person here. The only way this is going to work for me is that if I at least get a guaranteed rate of return that's satisfactory to me. And even though it's a low rate of return, I'm going to accept it. That person would be willing to loan you or give you $66,000 for your annuity. But somebody who was impatient and was looking at you, looking at Enrico, would look at you and say, I'm going to give you $48,800 and we'll be done and that's it. Because that person has a higher discount rate. Or to put it differently, you have a higher discount rate. You have a higher preference for spending in the present rather than in the future. And so that person is going to offer you much less money because they know you're impatient and you can't wait to be with Enrico. So that is an example of discounting. Well, that's what we have to do in benefit cost analysis. This was a stream of benefits. This was some schedule of discounting for the future that we have to incorporate into our analysis. The big question is, how do we determine what that value is? Let's go back to the spreadsheet. So here we have the slideshow. I've worked my way through it. Here's the examples that I just did. Isn't that great when I do it on the spreadsheet and it comes out looking exactly like like what I have here. Okay, I'm sorry, I don't mean to be so impressed with myself. But the discount rate, it's something that we have to pay attention to, and what's the rate that we're going to be dealing with. Why don't I do this again? Let's do this one more time. I'm going to do an example. I'm going to go back. I'm going to do another example. I'm going to go back to that spreadsheet. I have some things up here. I'm going to make this bigger, so just bear with me in a second. I'm just going to delete all of the values. And this is going to be a little bit of a learning exercise. Let's make this stuff bigger so you can see all the parts and they're okay for you to. Now this is going to be exactly what we were doing before. In this case, though, I have a project cost. Now, year 0, nothing's going on. I have nothing going on in year 0. Year 0 in this case is my construction year. Okay, so the present value of something in year 0 is its value. So my costs right now, let's just give them a nice big bold year 0. They're $3 million. So here's a project. I'm going to do something, and my project is going to yield, we've calculated a fixed stream of benefits that are just like our annuity example that I just showed you. They're going to be $400,000 a year for the next 10 years. And let's say that this is a 10-year project, that what we're doing with this project, the value of this project can only last 10 years for some reason, because there's physical constraints or something like that, or it was written into the law that it was a 10-year pilot project, and this is what we are going to do. Now, what we need to do is figure out at what discount rate this project is feasible. And I've got discount rates across the top here. We're going to pretend that they're some sort of viable discount rates that are appropriate to decision making, and we have some discount rates that we're going to go through here. And my discount rates are across the top. So we're going to do exactly what I just did before, and then I have my N, or my periods, over here, and they're arrayed from 0 to 10. So I'm going to calculate my net present values, and in this case, I'm not going to put them up in the top column. I'm going to do them down below when I do a calculation. So we're going to follow exactly what I just did before. I'm going to take the future value of my benefit, and I'm going to divide it by 1 plus my discount rate. That's up above. I'm going to put a $ in front of that discount rate. And I'm going to take that discount rate to, that little caret, to the period or the year or the N, which is the first one. And remember, I had to put a $ in front of that A. And I want to know in the present, year 0, what is that future income stream that's not going to show up until, start showing up until a year from now, after the project's done. What is the value of that? And we're already discounting it. So I can discount all of these values going across using that formula. And you can see as the discount rate goes up, the present value of those future benefits go down. This should suggest something to you before I go much further, that by manipulating the discount rate, you can reduce the benefits. By having the discount rate be too low, you can maximize the benefits. So you see where the room is here for messing around with benefit and cost? It's the discount rate, the appropriate, coming to the appropriate discount rate. So let's copy these down. Takes just a second. So let's copy our benefits down. So here's my benefit stream. It's a benefit stream. And look way over here. At a 9% discount rate, the future value of $400,000 is a tenth in the present value. So the buying power of that benefit literally has just evaporated. So, okay, so we have this stream. So let's sum our total costs. Well, our costs are fixed across the board. In every one of these, we know our costs are going to be $3 million. So let's just hit F4 and make that $3 million, and I'm going to copy that across, and every one of them has $3 million of costs. So this is going to be the denominator in my benefit cost calculation. What are my total benefits? Well, my benefits, as defined here, are going to be the sum of all of that, sum of all of that discounted future benefit stream. So we're just going to grab these values and we're going to sum them and sum them across. And so we get a range of benefits. Now remember, net benefits were simply the benefits minus the costs. So we're going to calculate net benefits are going to be the benefits minus the costs. And I have net benefits in this program at 3% discount rate, but look what happens as I move across. As the discount rate goes up, the net benefits go down. As a matter of fact, they're in the negative territory. So it only produces net benefits at a 3% discount rate. Therefore, of course, it only has a desirable benefit cost ratio, which is total benefits divided by costs. In the first instance, it has a benefit cost ratio of less than 1 in the other example. So in this case, unless we were dealing with a ratio, a benefit cost ratio of 3, we wouldn't fund this project. At 5, it's negative. It could be at 4. It's not. I don't know. I've never bothered to look. But in this case, given these examples where their increments were by 2s, at a 3% discount rate, this project would be feasible. We can do it at a 4% discount rate. Let's just do it right now. Let's say equals this divided by 1.04 to this power. We can do it. I'll just copy them down here. I'll just copy down because I'm curious. And then I'm just going to copy this benefit calculation over and answer my question. And indeed, at 4%, it would be a viable project too. It would have a benefit cost ratio. I can copy these formulas down now. Whoops. It's producing net benefits of $244,000. So even at a 4% discount rate. So I've demonstrated that you can use some precision here and you can get to an answer. But given the examples that I just gave you, given the choices that I just gave you, you could only fund this thing at a 3% discount rate. You could not fund it at a 5% discount rate. It was producing net losses to society, so you wouldn't do that. We can do this. Actually, I'm going to do a little bit more of a complicated example right here. And do I want to do this now or do I want to save this? Let's do it now. It won't take a second. Because what I want to do, I'm going to do it 2 different ways. I had to make these bigger because I'm showing them. Let's say we have the very same thing again. And I'm going to delete all of my numbers. And I'm going to delete my everything. I'm just going to delete everything. And I'm going to go up one more. And I'm going to delete, these are my benefits calculations as well, using the very same method that I just showed you. And I'm going to do this, but now I have a situation where I have a variable set of numbers. The first thing I have is my initial project costs, but let's be realistic here. My project has ongoing operational costs. I've got personnel, I've got maintenance, I've got evaluation, I've got I've got costs associated with my project. So even though it cost $3 million in the initial to build this thing, to keep it running over the years, I got to pay money. It costs us money. We have to appropriate money. Similarly, it's unrealistic to assume that the benefits are a fixed amount over time. Populations change. There's other kinds of things that we might anticipate as a consequence of this. And it could very well be that what we end up with is a benefit stream that grows over time, that's variable. So here's what I have. I have costs that are variable over the period of time, still lumpy in the beginning, but they're variable over a period of time, as well as benefits that are variable. Well, now I have to have a little bit more complicated of a table. I now have to discount my costs separately and my benefits separately. So, first of all, in year 0, we have our original value, 3 million. And so we can just copy that across, because that's going to be the same at all of these levels. So we have my original $3 million. In time 0, the present value of the construction costs are $3 million in time 0. And we're going to sum them up into the present values ultimately in a second. I'm going to get rid of these calculations down below. Delete. Just so I'm not confusing things. Now, just like what I did before, I have to now discount the future costs. So we're going to discount this divided by 1 plus the discount rate that we're operating with, and that's going to be divided. We're going to put a dollar sign in front of the row number. And we're going to raise that to the period that we're dealing with. And that's going to be to the nth or the first year. In this case, remember, we put a dollar sign in front of that A. There it is. And so I can now discount that future maintenance cost stream as well. So I can copy those across, and I've done that at the various discount rates. And whoops. I also have to do something else here. I have to put a dollar sign in front of my B25 because I'm always reading from the project cost column. That was a mistake. Fix that. There we go. There we go. Now you can see my costs values are going down as my discount rate goes up, so I can copy those all the way down. So I've got that. I've got that done, and this is all fine and good. So I can sum my total costs. I'm not dealing with benefits now, so that's why I've blacked it out. I can sum my total costs, and my costs are going to be the original cost at time 0 plus all of my discounted future values. And I can sum those across. Okay. Now, over here, I've got to do the same thing with my benefit stream. And so I don't have any benefits in year 0. So that's going to be, let's just make that gray. Nothing's going on in year 0. It's going to be the very same thing that we've been doing before. It's going to be the future value of my benefits, and I'm going to put a dollar sign in front of that C because I'm always reading from that line, divided by the 1 plus the discount rate, and I'm going to put a dollar sign in front of that 23, raised to the n power, I've got to do that, raised to the time period, which is going to be 1, and I'm going to put a dollar sign in front of that A, and I'm going to hit that, and I can copy that over across, and I can copy that down. And so now, let's see if we can compare these. Now I have a benefit stream, and now I have a cost stream. So I can calculate, because I have a benefit stream and a cost stream, I can calculate net benefits. Net benefits are going to be total benefits minus the present value of the cost. These have all been reduced now to present values. We're bringing them back to the present so that we can make a decision about them. And we see that under this one at 3%, it's producing net benefits at 3% discount rate. Let's copy this formula across. It's producing net benefits at a 5% discount rate, and it's producing net benefits at a 7% discount rate. Only at 9% does it produce negative benefits or net costs. So the benefit cost ratios are going to be the benefits for that discount rate level divided by the costs for that discount rate level. And what do we see? This project, given various discount rates, is producing a desirable benefit cost ratio of greater than 1, and it's producing net benefits to society under these three scenarios. So we would, if this was a government decision-making process, and we didn't quite know what the discount rate to be applied was, would be able to say with certainty that even at a discount rate that's considered extremely high, this project is producing net benefits. This looks like a very good deal for society. And if it ultimately came that there was a prescribed or a calculated discount rate that we were going to operate under, let's say it was 5%, then we would be able to say at a 5% discount rate, considering costs, which are lumpy and upfront, but have a stream of ongoing costs, considering benefits, which actually do rise over time, given those two considerations, this is a project that I would recommend funding. So what I've just done in this two-step example, first the simple one up above, and then this one down below, is show you how easy this is to calculate a discounted value, benefit and cost stream by converting future amounts into present values. Now, of course, where did I come up with the future amounts, and where did I come up with the future costs? Well, you know, that's where we start getting into the really hard stuff of benefit cost analysis, and it's actually beyond what we're going to teach in this class. I'm going to talk about what we value and how we value it a little bit down the road, but I'm not going to make you do it. Mostly what I'm going to make you do is be able to do what I've just done here, so that if you're a planner or a community developer or a project administrator and someone comes in and starts blowing you a project that says, you know, do, and it's going to produce these benefits to society, you're going to be able to say, oh yeah, show me. Show me your discounted present value benefit stream relative to your costs, and what discount rate were you using, and how do you justify your discount rate, and please show me your calculations, because I've learned over the years that sometimes people make mistakes. You show me all of this, and show me and give me a reason to have confidence in what you just told me. Well, I'm trying to give you the tools so that you have the smarts to ask that kind of a question of somebody who's making a pitch to you or making a pitch to your community. And your job, I believe, is best being the evaluator of these things as opposed to the producer of these things. And if you want to be the producer of these things, then it's a 3-credit class in benefit cost analysis that involves lots of math and lots of engineering principles. So I don't know that that's where you want to go, but I don't teach that class. Somebody else does. We're here in just simply learning and gaining a reasonably good introduction to this process. And that's what I've worked my way through here in this example. Now, when I start the next session, I'm going to give you a reasonable, I'm going to show you how you can actually do this whole thing with one little formula, which incredibly simplifies things, because when I was young, we didn't have that one little formula. We had to do it like this. We didn't even have computers. We had to use calculators, and I know why, but we can produce this kind of analysis relatively rapidly, very accurately, and get to the point of being able to make decisions just lickety-split. And I'll show you the formula for doing that in Excel that you can do, and you're going to use that in your subsequent assignment. I'm not going to get to your assignment for a couple of more lectures, maybe 4 sessions, but we're going to get to it. And what we're going to do now, we're going to wrap up after this session. We're going to kind of wrap up benefit cost analysis. And then what I'm going to do is I'm going to start moving into some decision-making criteria, but we're going to move into some case studies. So the last session will wrap up this benefit cost analysis formally, and then the remaining sessions we'll start investigating some case studies and see if we can't tease out what is and what is not a benefit, and maybe teach you how to read benefit cost analysis reports in a way that allows you to be critical. I hope this has been enlightening. It's always been good. I usually have good success working through this process. If you have any questions about this, give me a call or write me an email. I'm going to go through this, but I'm going to put this spreadsheet on the website so that you could actually look at it and see where the formulas are. But I'm going to wait until after I get done with this next session where I show you how to do it very easily, and I'll put it up after that so that you can look at this and see how I did it and understand and even save it in case you ever wanted to know how to do this yourself. Look forward to seeing you in the next session. Goodbye.